All right, so in today's lesson, we're going to be doing the algebraic manipulation of limits. And so that's it. In this process, we're doing three different things. We're going to find out, okay, what if we try just direct substitution? Then we may try to say, hey, listen, let's do some factoring to canceling out because I might be undefined as I try to do the limit, where I like divide by zero. Then we'll also have the case of when the limit doesn't exist. We also get to go through and do some trig limits as well in this section. So first part, we're just kind of in this direct substitution as we go forward with approaching limits, and we've talked about going from the left side and the right side of the number. Here we're just going to go straight in and say, hey, let me plug in this x value that the limit is approaching and see what do I get for a y answer. So we're just going to go ahead and try and plug it in. So that's my little note here. Try to plug in that x value. So with that in mind, we're going to say, okay, what's negative 1 squared plus 2 times negative 1 minus 4? So 1 minus 2 minus 4, that'd be 1 minus 6, so a negative 5. Now what we could do is we could go and graph our equation and see, okay, what is it doing as we approach that negative, as we approach negative 1 on the graph. What is it approaching there? And what we see is that it is approaching on the left side, and the right side is approaching negative 1. On number 2, we have the limit as x approaches 2 of 6. Well, on direct substitution here, we have to think about, hey, is there a x value for me to substitute in? And there's not. And so we got to think about is my answer is just going to be 6. We are creating a horizontal line more or less as I approach this one here. Remember that this, that is going to be our y value. And so this is just kind of indicates that, hey, I got the point 26 on the line that I have graphed there. So again, direct substitution, we're just putting it in there and seeing what do we get for an answer. And again, we can look at the left and right, the positive and negative side of that number, of the limit like we've done in the past couple lessons, and that would confirm what we're getting there. Next thing comes into play is, well, what happens when I go to plug in this case, the 0, and I have, in this case, I have 0 over 0 is what that simplifies to. And this, we're going to talk about it a little bit later more, but this is an indeterminate form. And so for the easiest stakes for today, and we're going to learn something later in another lesson, but for today we're going to say, okay, let me try to factor. When I get 0 over 0, let me try to factor to see if I can reduce out this dividing by 0 thing. So with that in mind, we look at the original problem. We notice that we can take an x out of the top, so it's x times 4x minus 5 over x. The x's will factor out, and I'm just left with the expression 4x minus 5. So now we're going to go ahead and take the limit as x approaches 0 of 4x minus 5. So that would be 4 times 0 minus 5, which is just negative 5. And that's what our limit is. Now, what would that look like on a graph? If you would go to graph this thing, what we would notice is it would graph only, if you graph the original equation, if you go in there to y1, and you put in 4x squared minus 5x over x, and you hit graph, all it's going to do is show a diagonal line. And at x equals at 0 comma negative 5, it's probably going to put a little hole there, is what it's going to end up doing. And it's going to put an open circle, is what it's going to end up doing. Again, our TI-84s may not show it that great. The Desmos might work better on showing the open circle. But that's what's ended up happening is because the calculator is going to reduce out the x so we can draw the diagonal line because that's what it simplifies to. But then it's going to put a little open circle at that negative 5 saying, hey, this original equation, we have a hole there. And again, sometimes the technology may not show that. Number 4, as we look at this one, we can see if we put the negative 7, it's going to make the bottom 0. And so with that in mind, I'm thinking, let me think ahead. Let me try to factor the top. Now, usually, whatever they put on the bottom there, like that x plus 7, that's probably going to be one of the factors of that expression on the top. So we're going to kind of bet that it is that way. And so I got to think about, okay, what do I multiply in order to get that to work out to be the expression on top, and it's a 2x minus 1. And then now we can reduce out the x plus 7s, and then I can find the limit of, as x approaches -7, of the expression that I have left. So that would be 2 times -7 minus 1, which would be -14 minus 1, which is -15. So again, we're still using direct substitution, but we're just got a beginning first step of trying, when we notice that we're dividing by 0, hey, can we factor, get something reduced out so that we can go ahead and do the direct substitution to find out what my limit is. And again, you can graph the original problem, see what it's doing. I highly encourage that. Again, Desmos might be a little bit easier to manipulate with and zoom in and out compared to the TI-84. So now on the next one, we see that, yes, if I put in a -6, it's going to make the bottom 0. So I want to start to go ahead and think about, okay, let me try to factor. And so as x approaches -6, the top and the bottom, we already know is an x plus 6. Now, it's a plus, and when I notice, I say, well, I got to make a 3. Well, the only way that happens is with a 1 and a 3. And then I notice there's no reducing going on here. And so when we end up working this problem, what it end up happening, we'd have -6 plus 1 times -6 plus 3 over -6 plus 6, which that'd be, let's see, that's a -5. That becomes a -3, so that becomes 15 over 0. So in that case there, we would just say that this does not exist. Again, we can't reduce it out, and so this is a case where we say the limit doesn't exist. And if we go to graph this problem, and again, this is going to be a really crude-looking graph, we would see that there is an asymptote at -6. There's an asymptote, and the graph basically it's not like the 1 over x graph. It's kind of curved down there and curved right there. So it kind of it doesn't look like the 1 over x graph. So it's kind of more instead of hugging the axis, it actually goes back up towards infinity as we do it on both sides. Again, take a peek at that, looking in the calculator, get a good idea of that. So now we got our special trig limits, and my thing here is just got to memorize. I get to teach you something here later on in the chapter, L'Hopital's rule, to help us with some of this kind of thing. But right now we're just going to do flat memorization. When we say that I have the limit as x approaches 0 of sine x over 1, or sine x over x, the answer is 1. Even if I reverse the 2, the answer is still 1. If I'm taking the limit as x goes to 0 of 1 minus cosine x over x, the answer is 0. And if I reverse the two things, then the answer is, at least reverse the two things on the top compared to what we had before, doesn't matter where the minus is, we would still say the answer is 0. And again, when we learn about L'Hopital's, we can go through that a little bit further and why it works out to be the way it is. But right now, I think it's just easier just to memorize as we do it. So as we have a few more problems left here to go through, they want us to figure out, okay, what do these limits work out to be? And there's a couple things that you can do it depends on where your brain's with, kind of handling this topic. One thing we can do, we know if we put the 0 in there, doesn't look good, and it resembles a little bit. It sort of resembles that first thing. The challenge is we got that 3 on the x. That's the challenge. So if we can make the number or the term on the bottom, the x on the bottom, resemble the 3x after the sign, then we can use what we know the limit is as it approaches 0. So what we can do, we can cosmetically change this problem is if I want to make sure I match the 3x on the sine 3x, and all I have is an x on the bottom, I can actually multiply the bottom by 3. But that also means I got to multiply the top by 3. Whatever I do to the bottom, I got to do the top. So with that in mind, now I have the limit as x goes to 0 of 3 times those things, these now we can say become the 1. They kind of match here. The coefficient on the x and after the sign and the coefficient on the x in the bottom, they match. And so we can really just say this is 3 times 1 or just 3. Number 7, kind of the same thing. We can rewrite this a different way. We can rewrite it from the standpoint of sine 7x over 1 times 1 over sine 9x. And then if we do our little changing, I can put an x on the bottom, so I can multiply the bottom by x, and I can put an x on the top. And if you want to go to this, to me, I'd probably just stop right there, because I should realize that I really don't have to multiply the bottom by 3. In a loose way, the coefficient on the x after the sign is going to come out front. I can if I want to. If I want to change it and I like it, I can say, okay, let me put a 7 here and a 7 out front, a 9 here and a 9 out front. And then when I take the limit of this thing as x approaches 0, we're just going to have 7, and then it's time the sine 7x over 7x. We know that's going to become 1. And then and then on the next part, 1 over 9, and then that's times 9x over sine 9x. And so this really becomes 7 times 1 times 1/9 times 1, which gives us just 7/9. And so it's a lot easier sometimes just to say, hey, it's just the coefficients on all those things. We're not factoring it out because that would be bad mathematics. But in a shorter way of thinking, it's really the ratio of the coefficients on the x's after the trig word. Now, as we look at the number 8, the last one, here it'd be kind of hard to go through and multiply, but I do see some things here. I see a difference of squares on the top, so I'm going to go ahead and factor. So this is the limit as x approaches 0 of cosine x minus 1 times cosine x plus 1 over x times cosine x plus 1. And then I look at it and I say, okay, those two things are common factors. I can get rid of those. And now I'm going to clean it up. Limit as x approaches 0 of cosine x minus 1 over x. I look at that, then all of a sudden I look up above. I say, hey, that's that little guy right there. So that means this has to work out to be 0. So again, replay this if you need to. Again, this is kind of, there's a lot in there. I'll have an extra, finish up this classwork, the homework part. Be ready for maybe an entrance ticket tomorrow when you come to class, a mastery check on this stuff, and then I'll also put some more exponent laws worksheets out there for you guys to work on as well.